Okay, so heat up process. When the castable is properly dried, it contains 2.5 to 5% water, which is chemically bonded with cement. This water is removed at various temperatures, but the majority comes off at 500 to 600 degrees Fahrenheit. For this reason, it's recommended that the temperature be increased at a rate of 50 degrees Fahrenheit per hour to 1,000 degrees. With a hold at 600 degrees for 1 hour per inch of lining thickness. We have 3.5 inches at the thickest point. And then you increase 50 degrees per hour up to 1,000 degrees. And then once you hit 1,000 degrees, you can increase your degreeage per hour by 100 degrees until you hit your desired operating temperature. We're not sure what that desired operating temperature is yet, so I'm just going to run this burner to the max. And we're going to see where we get to with it. So I cheated a little bit. We have an industrial oven across the street. And so, because it requires a 12-hour bake at 230 degrees, I did that in the oven, and then I slowly increased it to 350 degrees until this morning. So I baked it for a total of 17 or 18 hours. Once I got it out of the oven, I insulated it with some kale wool. I brought it back up here, and I immediately put the burner in, and I've been trying to modulate the temperature of this thing as best I can with this POS Harbor Freight burner. But granted, it was only $19, and I'm sure it's going to get the job done. The first time I shoved the flame in there, it hit 1,900 degrees, and 1,200 degrees, and I haven't even squeezed the handle yet. So we are. I'm running it right now. We're at 660 degrees. You missed a lot. This thing's been going for quite a while already. But I'm going to hold this now for 4 hours, and then I'll do an update as I increase it, and increase the temperature. I'll stop and do an update. But I mean, you can see the setup. It's pretty simple. Have the digital temperature probe. Whoops. Digital temperature probe, and the keg, and you're going to be able to hear I'm doing a couple other. I'm trying to finish that table for the lathe right now at the same time, so there's going to be some. You're going to hear this thing running in the background the entire time. Sorry for that, but nothing I can do about it. I just happen to have free time, so I'm trying to maximize my free time as best I can. Excuse me. So that's that. I'll keep you updated. Okay, so it's been about 4.5 hours. I haven't been paying attention to this thing at all, and apparently I should have been. I don't know if you can see this. So this thing just fucking totally ran away from itself. I don't know if it's the burner. I mean, I don't know what it is. We could open this thing up after it's done, and it'll be a total piece of shit. So I have no idea what's going on. This thing's not really a consistent probe either, because just moving it changes the temperature. So this thing started out, it was 640 degrees, and it was pretty consistent. Oh, now we're dropping. Maybe it is the probe. Maybe I just had the probe in a hot spot. Well, let's see. Maybe I'm just all wet on this. No, it's going back up. So it's stable around 1,000 degrees. This probe's rated for about 1,200. So I'm going to just keep letting it cook until it destroys itself. And we'll look down in here. I don't know if you can see anything. There's some blue flames rolling up. And also we have some cherry redness going on the one side of the lid. So it's getting hot. And it's going to do what it needs to do. But just so you guys know, this will be a video on exactly how not to fire the concrete. I think probably if this thing's okay, my only saving grace will be the fact that it baked for almost 24 hours before I fired it up, and at temperatures up to 350 degrees, which is nowhere near 600, which is when this thing sheds all the water from inside the concrete. It's also been curing for close to 4 or 5 weeks. I mean, this thing's been sitting for a long time before I fired it up. It's been inside of a building. It's been a dry building. It's been covered, not much dust inside of it. But this Harbor Freight burner is such a steaming pile of shit. I'm assuming that's why everybody else makes their own. I don't know how you control this thing any finer. I mean, just a tiny little blip of the knob and this thing's all over the place. So I would say that we've gone from 600 to about 1,000 degrees in 4 hours, which is as prescribed if the keg was 600 degrees at the beginning. So it wasn't. It was around 350. So who knows what's going to happen. This thing could explode at any moment, and the concrete could explode and chip off the sidewalls. But I'm just going to let it go at 1,000 degrees for another hour or so, and then I'll start cranking the heat up and see what this thing looks like and how it acts. And then after we fire it, I will take the stuff out from in between the lid and the rest of it, and we'll cook this thing full tilt boogie. We'll give it all she's got until she gives up the ghost, I guess. But I figure a couple more hours at this temperature, that'll put us right around 5 o'clock p.m. Then we ought to be able to do something with this thing. And hopefully the next time you guys see this thing, we'll be casting some aluminum. Actually, we'll be smelting down some aluminum to make some ingots and maybe some material for the lathe, maybe some round bar. Round bar is pretty amazingly handy. I might make some round and some, I don't know, who knows, we'll see. But this is just an update. Sorry I missed it, and sorry I wasn't paying better attention to this thing. But if this turns out, this will at least give you guys an idea of how critical the original cure directions are. Maybe this will affect the integrity of the unit, I don't know. Hey, what are you going to do? You know, it's too late now. The damage is done if there is any damage, so we're just going to hope for the best. I'm actually going to try to shine a flashlight in here and see if I can't see anything. See if maybe I see any of the concrete falling off the walls. See what everything looks like in there. But, I mean, this burner, this Harbor Freight burner would certainly... Yeah, I mean, I don't see any flakes in the bottom yet, knock on wood. Don't. Yep, and I haven't even seen any steam, and I haven't seen any water condensating on the ground underneath this thing, so I don't know. Maybe that's the difference between me and Brian's. Maybe the fact that mine sat longer before I ran it. Like I said, it's been close to 5 weeks. I'll have to go back and look at the dates on the original video when I first started making the castings, but it's almost 5 weeks. But anyhow, I'll keep you guys updated. I'll do another one here shortly, and I'm going to keep on working on the table in the meantime. Alright, here's another update. Power this on. We'll see where we're at right now. Still around the same temperature. It's been about another hour. Like I said, I'm just going to keep rolling like this for a little while just to make sure I've gotten all the water out of everything so that it doesn't separate and split and piss and carry on and become problematic. But if you can see in there, we got a nice little cherry glow. Flames are actually coming out of the top of this thing, which I don't know if I ever noticed that on Brian's, but it may just be because I don't have enough oxygen in my reaction. I'm pumping too much fuel in this thing. But in about another 30 minutes, I'll fire this thing up and we'll turn the heat up and we'll see what happens. Alright, so my second alarm just went off. And that was another 2 hours at, I don't know if you can see that. It's about 1100. Oh, there we go. It just fell out. I'm sure that's not hot at all. It was 1100 degrees. This thing dies at 1250, I think. So I am we're gonna see what happens. Just turn it up until if it eats this. If it eats this guy, then it eats it. 1300. I think it's all about the placement of the probe. And I don't know what temperatures does what, so we're gonna give this a little crank up again. I think we're actually going to pull the metal out of there. We're going to get the temperature probe out of there, and I'm going to let this thing roll like it is right now for another couple of hours maybe. I'll turn it up a couple more times, do it all on camera so you guys can watch me blow myself up. But right now, I don't know if you can see it, but there's a blue flame shooting right out of the top of that. I really need to read the instructions and figure out exactly what this valve is doing. Because it can't possibly be introducing oxygen, so it's got to just be adding propane. And what I need now is more oxygen. But I'm just gonna let it keep rolling, see what happens. Who knows? I'm gonna let her go. All right, so I wish I'd have left this running as usual. I wanted to see how much fuel I was wasting with this thing cranked up. So what I did was take a acetylene torch and drag the flame right across the top of the furnace, and I had blue flame sticking out of this thing this high. So I've been doing nothing but wasting propane. I think this is a pretty good burn for this thing. I mean, it's been hot for 27 hours now. Not flame hot, but it's been being cooked for 26 hours. So I'm going to cover it with the kale wool over there on the skid. I'm going to cover the side hole and put something on top of it. And we're going to let this thing cool down naturally overnight and see how it turns out. But before we do that, I'm going to give you one last view inside of this thing so you can see what this thing looked like. See if it's still red in there. Not really as hot as it was. I feel like we were just wasting fuel. I got to get my oxygen mix right. I mean, there's still blue flames coming out of here now, so we're nowhere near efficiently burning this furnace. I'm going to work on that. I'll have to, before we cook this thing next time, I'll get a proper burner made, and that'll be another video that I won't get a chance to post yet. I haven't posted any of these videos, so this is all just going to be well, I guess it's kind of a nice backlog for me. I can just keep posting them and do my one a week duty. Sorry about the noise. I have some exhaust fans going. Ever since I realized how much fuel we were wasting, I've realized that the entire day I've been here, I've been breathing it. So I'll try to cut this. Very much like fiberglass. Well, beep, 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 and that's all, folks. I will make another video whenever I open this thing up for the first time, and we'll see what the inside looks like, see what the condition of the concrete is, see if I ruined anything, make sure everything's still okay. Who knows? Alright, so this will be the final video in this series. This will be the unboxing. No, actually not even the unboxing, but this will be the final product. After cooking this thing for close to, well, it was it was from 1 o'clock in the afternoon is when I started the oven. So it started then, and it took 6 hours to ramp up to 250 degrees, and it held 250 degrees for 12 hours, and then it ramped up to 350 degrees because it never ended up making it the whole way to 600. And then it held 350 degrees for almost another 12 hours. So after it baked for 24 hours, I then got it out of the oven, brought it up, and started the cheapo Harbor Freight burner, which I can tell you that in hindsight, I probably would have made a burner first before doing this, but I didn't know. Nobody in any of the videos says anything about how terrible those Harbor Freight burners are, but they're just not consistent. They're not uniform. It just doesn't seem like the heat adjustment on them is you know, a linear curve. It kind of fluctuates, and it ramps up, and it just grows and grows and grows. But we were able to get this thing to 1400 degrees Fahrenheit, and I was able to hold it there for a good part of 4 hours. So we're going to take the lid off this thing and see what it looks like. So in hindsight, I probably should have left the Satanite. We do have a little bit of breakup and chipping up here along the top where the lid rests. That's probably partially my fault because the stainless steel ring doesn't stick up above the concrete. The concrete's actually above it. But other than that, tell you what, let me get a flashlight and we can take a look at this thing. Oh no, it looks pretty good. I don't see any cracking or splitting on the walls. I was really concerned about what would happen up in this area because that's where that's where I ran out of concrete when I was pouring this barrel. I think actually the only thing that did crack would be this guy, and it looks like it is split up pretty good through there, but I mean, this is just something for me to set the crucible on when I'm cooking this stuff. So other than that, the sidewalls look good. Everything seems to be holding up real nice. This top, I probably would have done it differently if I could. Actually, to be honest with you guys, I would have done this whole project differently if I could go back and do it again. This is, I don't know if you can see this lid or not. See the lid? Yeah, you can see the lid. What I would have done, probably, very likely, I would have bought more of this Kailwool. I'd have bought a huge roll of it. I'd have got the highest heat rating I could find, which would be the most expensive kind you could buy, I'm sure. But I would have laid a, one sheet layer in the bottom. I would have cut it out using the top. Would have laid it in there, cut around the top, pushed it into the bottom. I would have then filled it with concrete, probably pretty close to as thick as it is now, maybe a little bit thicker, and then I would have let that cure. I would have then gotten a thinner roll, half-inch thick. I know this stuff comes in different thicknesses, but probably something half-inch. I mean, this stuff looks like it's you know, I mean, that's pretty thick. That's 1 inch to 1.25 inches. And I would have wrapped the inside of the barrel in it before I did the rest of the concrete. This concrete doesn't insulate very well. I mean, it's not like having the flame directly against the outside of the barrel by any stretch of the imagination, but I think that layer of kale wool not only would it have saved me a pile of money when it comes to the concrete, because like I said, this is $300 worth of concrete and mortar in here. It's 200 pounds. It's 200 and some change. The barrel's 157, and the lid is 57. So, I mean, that gives you an idea how much this thing weighs. The kale wool would have not only have helped lighten it up, but it would have also helped insulate it better. Would have been a better insulated product, and also, you know, if you guys don't feel like making the forms and casting this thing, you could realistically just line this thing with kale wool, put some kind of a stand in the bottom of it made out of concrete or mortar for your crucible to sit on, and that would have been so much easier. Plus, when the kale wool gets crappy and garbage-like, you can just pull it out and throw it out. Slap some new stuff in there and just keep on keeping on and rock and roll. Next project's going to be the burner for this guy. Almost have all the fittings here. I have a couple more that I have to get, and after we get them, then I'll do a complete burner assembly video, and we'll try firing this thing up again. I got to make some crucible tongs yet, and I don't think I'm going to fire this up again until the burner's made and I have crucible tongs. And my plan with the crucible tongs will be to make them make a version different from Brian's, but not like what you would buy off of Amazon. I like the fact that his have the pouring capability, but I don't like the squeeze handle setup of his. I just think that adds a layer of complexity that doesn't need to be there. And we'll make those, we'll make the burner, and we'll see how you guys like it. I'm going to start posting these videos here shortly, and we'll see what kind of a response I get from you guys. This is nothing like Brian's. Brian spent so much time on his. He's incredibly talented. I just wanted this to be as down and dirty as possible. And, you know, not even really that, because I have some equipment at my disposal that makes my life a lot easier than it'll make most of yours. But just to show you that if you don't have CAD software, you have a good head on your shoulders, you can pretty much accomplish anything you want. I mean, this is, for lack of a better word, this is kind of schlapstick. Even though I have the tooling and the capability at my disposal to make this thing absolutely flawless, my real objective was just to get something that's functional, get something that's done that I can actually use. I've been dying to have a furnace for a long time, probably ever since I bought my 3D printer. And when I watched Brian's video, I've been dying to build one. So now that I have one, now I have to wait to get my burner built, the crucible tongs, you know, a degas tool, and something to scoop the dross off the top of all that stuff. But I'll end up making all that, and hopefully the next video that you see of this thing will be this thing cranking itself and running up to 2800 degrees with a crucible inside of it, and we'll be melting some copper or some aluminum or all of the above. You know, I'm really interested in casting some stuff. I'd like to, you know, recycle a lot of the waste material that we get here. We have a lot of byproduct, you know, processed byproduct, and it would be really nice to be able to recycle that bronze, recycle that aluminum that's just thrown out, melt it down, and cast it into, you know, cylinders and square pieces, you know, just miscellaneous material that I can put on the shelf that I can have at home for my small lathe. Well, it's actually a machining, sort of. It's a 3-in-1 combo machine tool. And just have a bunch of material laying around that I'd be able to use to make anything that might come up or crop up. But I mean, I'm really pleased with how this thing turned out. I think it looks really good. You can see the black smut that's in here, which is basically unburnt fuel, pretty much. It's carbon, I'm sure, but it's just to prove how rich this burner was running. That Harbor Freight burner that I had was running. I I cranked it up as high as I could get it to go, that I was still getting flame inside the barrel, and it just wasn't getting any hotter. And I took an oxygen propylene torch, and I struck it, and I was waving it over the top of the furnace about a foot high, and I ended up getting a foot high flame coming out of the top of the furnace as well as what was running inside. So it was a seriously inefficient setup. Lots and lots of wasted and unburned propane. I think that it is incredibly important to have a burner that you can finally control the amount of oxygen and fuel that you're delivering to this setup to really get as an efficient a burn as you can possibly have. So, but this is it. I hope you guys liked it. I hope you guys keep tuning in, and hopefully there's more to come. I'm going to keep doing this until you guys, I'm just going to keep doing it. It's because I think it's nice to share this information, share your abilities, and hopefully, you know, we can get together with a bunch of guys and collaborate some projects and just do some really neat things to show you guys. All right, see ya.